Hi, chemistry students. I'm trying to get my document camera up for you. Just give me a second here. Sorry for the delay. It's not working very well. Um, Sorry for that. Just trying to get everything set up. So yeah, so we're looking at the lab that we did on Monday. And for many of you guys, we did go over, talking about how we're talking about hydrated samples. Okay, so I'm hoping I didn't quite get a chance to visualize the reaction, but I'm gonna submit in this assignment another sample being done, maybe by another teacher, just to have something available for anybody that was absent that would want to see the actual reaction a little clearly through a video. So along with this video going over the worksheet, I'm also going to have a video of the experiment being done by another teacher. So I didn't mean to turn that off here, at least the screen here. So back to what we're doing there. Sorry about that mistake. But make sure that you've written out the purposes. I asked you guys that before. I'm hoping this is the same thing that we had on the screen, but I hand wrote it out for my video tonight, making this for the day because I'm not at school right now. So that's why I'm recording this. But we're going to be measuring out hydrated samples by mass. That was one of the things we were doing, trying to just go back and measure materials by mass, which we haven't done since last fall, working with measurements. So we were doing that, and then we were observing the loss of the hydrated samples with its loss of water when we heated it. So we're observing its loss of water, the hydrated sample's loss of water. And then the final purpose is to determine its ratio of water in this sample. So we're trying to figure out how many waters are going to be in this particular sample of copper sulfate, okay? So originally the chemical is blue, and revisit the other video to watch the actual reaction, but it's a blue chemical with water. And then we heat it up gently for about 10 minutes. And after heating, we waited till it was gray in color. And this is without water. This is without water. So the blue version is with water. The gray version was without water. And we had samples that were any kind of mass. Some of you guys have around 5 or so. Some of you guys only have 1 gram. You also had the mass of your empty bowl, and you want to be sure that you don't include the mass of your empty bowl. So make sure that's going to be somewhere around 20-ish or 40-ish. I'm not going to put exact number down here because everybody's bowls was different, okay? But you want to make sure you don't include the mass of the bowl in your beginning mass. It should hopefully be somewhere between 1 to 5, maybe even 6 grams at the most. If you have something in the 20s or up to 40s, then you need to take away the mass of the bowl, okay? I'm going to use these numbers here that I had from one of the groups. I'm going to make my beginning mass at 2.70. A lot of you guys have something that small. And then after heating, it went down to about 1.79 grams. So you notice this loss of mass. And after the quiz today, with many of you guys, I was trying to show how do you get that mass, how do you get that percent of the loss of this chemical? And what we're losing is the loss of water. So our answer down here is, what is the chemical loss during gentle heating? It's going to be water. Okay. And then how do we get the percent loss of this chemical? Notice how much of it went lower. So you want to be subtracting these two numbers. You're going to take and subtract, okay? You're going to subtract the beginning mass minus the after heating mass, the after heating mass. and that's going to be 2.7 minus 1.79. In my sample, it equals 0.91. You guys use your two numbers here. And again, it has to be the numbers that don't include the bowl. If you do have the bowls for both, it could suffice and subtracting the two, but it's just easier if you go ahead and do the mass of the beginning powder, not including the bowl, and the mass of the after powder without including the bowl. Have those two numbers. You're going to subtract those two, and that loss of mass is going to be the mass of water. You're going to figure out the percent loss of this chemical. So 0.91 is the grams of my water, and the beginning mass, you divide it by the beginning mass. So you're going to take your mass of water that you have divided by the beginning mass. So I'm going to put beginning mass, and that should be, the mass of water should be less. You take that and you times it by 100. That gives you in percent. Okay, so I'm going to use my numbers of 0.91. That's when I subtracted 0.91 divided by the beginning mass of 2.70 grams of the hydrated compound. Okay, and so I'm doing my math here, and I have I think I don't, hold on a second. I thought I had that figured out. I guess I forgot to have that ready. So it's going to be 0.91 divided by 2.7. And that is a decimal, and you times that by 100. Okay. So I'm getting about 33, almost 34%. So it's 0.337 times it by 100, and we get 33%, 33.7, sorry, I should use the decimal here, 0.7% water loss. Now, you guys could have anywhere from 30-ish might be a little too low, but 33 to maybe even 40-some percent. It could be even higher, but go ahead and work with your numbers. If it is a lot higher, that happens sometimes. Sometimes we overheat it. Sometimes we don't heat it long enough. So I got 33% water loss. You take the beginning minus the ending to get the mass of water, and take that difference divided by the mass of the beginning to get a decimal, and then times that by 100. Okay. Now, the other part of what we're doing is to figure out what the ratio of water is to this hydrated compound or sample. Okay, so what we're going to use is we're going to figure out the moles of water. We got to figure out the moles of water, and we have to figure out the moles of the dry compound. Okay, so by doing so, you're going to need the molar mass of water, and you have to get the molar mass of copper sulfate. Okay, so we have to get it of water. Remember, H2O, and you're going to do water a lot for a lot of different things, including this homework. So you're always going to have OS16, 2 H's is 2, so you add that together, it equals 18 grams for every mole. So what you need to do is to take your 0.91 grams of water and convert that into moles. Okay, and we're going to be always taking mass to moles. You're going to be taking the mass divided by the molar mass. That's how you get moles. So you're going to take your grams of water, whatever grams of water you have, the number of grams of water, you're going to divide it by 18. Okay, so you take your grams of water and you divide it by 18. And when you get this number, you're going to get a number less than 1. It's going to be really small. I'm going to take 0.91 on my data and divide it by 18. And you're going to get a decimal of 0.0 something, okay? And it's going to be small. So when you divide it by 0.91 divided by 18, you're going to get a decimal like 0.0500 or something small, but you're going to have probably something 0.0 or maybe even 0.00, you want to include 3 decimals past the first zero. So we're going to use 0.0506 to round it up, and that's your moles of water. Okay, so you're getting the moles of water by taking your mass of water divided by 18. Okay, then you're going to be converting your dry compound of copper sulfate, excuse me, you're going to take your grams of dry powder, and that's copper sulfate. So you're going to convert your grams of the dry powder. This is the dry powder. So you're going to use this mass for number 4. Okay, you're using this mass here, the water mass, in number 3. So I'm going to star that and use that for number 3. Okay, just so you know, you're going to use that. Number 4, you're going to use grams to moles, and then the grams of water, you're using this in number 3. That's why we use 0.91 grams divided by 18. Take whatever grams of water you have and divide it by 18, and you're going to take it as past the first zero. Do at least 3 numbers past the decimal, past whatever you have the zeros. This is a small number, okay? Then we're going to do copper sulfate. You have to get the molar mass of copper sulfate. That's 1 copper, 1 sulfur, and 4 oxygens. And so that's going to be 63.5 grams, and that sulfur is going to be 32 grams. And my pen is running out of ink, so I got to use a pencil here. I think I don't have another pen around here to grab. Sorry about that. So we have 63.5 grams of copper. We have 32 grams of sulfur, and then we have 64 grams of oxygen. Okay, so we're going to add that up. 63, 32, and 64. That equals 159.5. Now, I'm going through this again just for anybody that didn't see see me doing it after the quiz yesterday. So some of you guys already have the 18. Some of you guys already figured this out, but this is mainly for you guys that didn't get the full. We either just got to the percent of water, or we didn't even get through this at all yesterday. So follow my work here, okay? So we figured out the grams we figured out the grams of water. We put our grams of water to moles of water by dividing it by 18. And then we're going to take our grams of the dry aftermass and convert it to moles. So we're going to use the 1.79. You guys have a different mass, different numbers, but you take your mass of the 1.79 grams of the dry copper sulfate, and we're going to divide that by 159. So let's go ahead and just divide it by 159.5. Okay, just like you did the grams of water divided by 18, you're going to take the grams of copper sulfate and divide by 159.5. Okay, so you're going to take the grams of copper sulfate divided by 159 for number 4. Remember, for number 3, you're going to take grams of water divided by 18. Okay, so we're going to take 179 divided by 159.5. It's going to be even smaller. So I'm going to do 1.79, whatever your final mass is, divide it by 159.5. And I got even a smaller number. So I have it equaling to 0.00, excuse me, just 10, sorry. 112. Okay. Moles of copper sulfate. Now, each of you probably have a different number here and a different number here, but you should have more moles of water to moles of the dry compound. And in most cases, that's what's going to happen, okay? But we want to take this as a ratio, okay? We're going to take the 2 amounts of moles into a ratio. We're going to divide the 2, okay? So we're going to take the answer for number 3 and divide it by the answer for number 4. and that's going to give you the number of waters in the compound, okay? And that's going to tell you, that's going to be a ratio. You're making a ratio of the two. And you should have more water moles than copper sulfate moles, okay? So we're going to put our 0.0506 moles, and you can divide it by 0.0112 moles. And this is of our water, and this is of our copper sulfate, okay? So we're going to take those two and divide them. It looks almost like it's going to be close to 5, which is what we like. 0.0506 divided by 0.0112. And that's actually closer to 4.5, but that's pretty close. Sorry, this works out to close to 4.5, which rounds up to 5, okay? And so that means that up at the formula, okay, originally, which I forgot to mention here earlier, because we went over this earlier, but we have copper sulfate, and what we're trying to figure out is that actual number of waters. And your lab data hopefully is going to be close to 4 or 5, maybe even higher, okay, 4 or 5. And you're going to, that's what it's going to be for that number up there, okay, for that, what that is. And doing this ratio of moles of water to moles of copper sulfate is ultimately what you're doing to get the number of waters in the compound, okay? Now, on the other side, and you do your best to try to do your math here, work on it, and then I'm going to check it over on Thursday, okay? Even take a walk around the room while you guys are working on other problems to see how you're doing on it, okay? If you want to send me a picture of your work and have me check it tonight, feel free to send me a picture by remind, okay? Now let's take a few other minutes. I wanted to show you how to get the percent of water in any hydrate with the formula, okay? And then also doing one other compound, but with copper chloride. And then I even have a third one, but I don't know. My video is getting pretty long. I don't want to take it up too long today. So I'm going to definitely do these two in this video right now, and then possibly talk about this last one with you guys, or wait till we get back together on Thursday. Now, we also, originally, we went over these the day before. Remember how this is iron? This is, my pens, hold on a second. One moment. This is iron chloride, okay? And then we have 6 waters. So we're going to say hexa hydrate, okay? And then we're going to have copper sulfate, and it has 5 waters like we just got on the lab, pentahydrate, okay? We also could do some naming. I'm going to have some multiple choice questions you're going to do with some naming, okay? But we have barium chloride, so we're going to put Ba plus 2 chloride minus, so we're going to do 2 chlorines with 2 waters, so put a little dot there. And then we have magnesium sulfate. We're going to use magnesium sulfate for the first example. So magnesium sulfate is Mg plus 2 sulfate minus 2, and we have 7 waters. Okay, so we're going to use that formula and actually look at how to get the percent of water, but we're going to use it from the molar mass of the whole compound. Okay, and so we could easily calculate the percent of water lost, and then you can get the percent of the dry compound as well. Let's go ahead and answer these questions, and I'll set you up on this one. Then we're going to do another problem with copper chloride, trying to figure out the X, and another set of steps that will hopefully show you the steps on how to figure out the amount of water that's in a hydrate, okay? So if you look at the formula, there's magnesium sulfate with 7 waters. So it says how many moles of water are with each hydrated compound of magnesium sulfate heptahydrate. Obviously, you see hepta, so the answer is 7, okay? Now, how do you get the percent of water? Let's go ahead and get the molar mass of the entire compound, but then just take the water mass over the whole mass, Okay, what that would look like is you're going to take 7 waters, okay, 7 waters molar mass over the entire compound's molar mass. And take the 2 of them, just like we did a percent composition earlier. You're going to take 7 waters, that mass, over the entire mass. Now, when you see the dot, don't worry about the dot. You're not doing any multiplication. You are actually adding these together, okay? So we're going to take the mass of 7 waters, and when we get this fraction, we're going to take this and multiply it times 100 to get it in percent, okay? Let's just wait on that because I want to go ahead and set up the numbers, and then we'll multiply by 100 at the end, okay? So we're going to take 7 waters. Isn't that going to equal 7 times the 2 H's and 1 O? Isn't that 2 times 2 plus 16? Isn't 2 plus 16 equal 18? Let's go ahead and just write that down as 18. But I reviewed again with you what the molar mass of water is. So we're going to do 7 times 18. That's going to be the top mass, divided by the mass of magnesium, a sulfur, and 4 O's. Now, isn't magnesium on the periodic table 24.3 plus 32 plus 64, because you have 4 times 16, 4 times 16, okay? And so you're going to add all that up. We're going to add all this up, this part here, plus you're going to also add on the 7 waters. So we're going to take, and we're going to add this to 7 times 18, okay? So let's go ahead and do the math here. What's 7 times 18 here? 7 times 18 equals, hold on a second. 7 times 18 equals 126. Okay, 126. And then you add all this up together, 24.3 plus 32 plus 64 plus 126. That adds up to 246.3 grams. Okay, and these are grams per mole. Okay, so you're basically taking 126 divided by 246, take that as a decimal, and then you're going to times that by 100. Okay, that's what you do when you do percents. Okay, so we're going to take 126 divided by 246.3, and that equals 0.512. So that's almost like 50%, over 50%. So you're going to take 0.512 and times it by 100 to get 50%. 50%. Okay. That has 51% water. That's a lot. Over half of the compound is water. And then what is the formula of just the anhydrous compound? That's going to be the formula just with magnesium sulfate, not with the water. So you're just going to put MgSO4 here. Okay, that's the anhydrous form. Okay, so let's do one more together, and then let's have you do some problems, some questions on quizzes, okay, after this. So we have copper 2 chloride, and copper 2 means it's plus 2 copper, chloride's minus. So we're going to do CuCl2, and we're trying to figure out this number of waters. So the anhydrous compound has a mass of 4.5. That's the before. And then we have just the dry compound. The dry copper chloride is 3.54 grams. So what do we got to do like we did on the other paper? Okay, didn't we subtract these two, right? So we're going to subtract these two, and that's going to be your grams of water lost. So you want to go ahead and subtract these two to get your water lost, and this amount is going to be 0.96. When you subtract it, it's just a little bit less than 1. And so you have grams of water lost. You have the grams of copper sulfate. And so our next step is to take our gram. So that's step 1. Okay, that's step 1. You're going to subtract to get the amount of water lost. Your second step is to convert grams to moles of both water and of copper chloride. Okay, you're going to do each of those numbers and convert those from grams to moles. You're going to take this number here, this number here, and this number here, and convert both. That's exactly what we were doing on we were doing this on step 3 and step 4. Okay, but the compound's not copper sulfate. The compound's different. Okay, so you're going to do the exact same kind of setup, but you have to use a different molar mass of your dry compound. So you've got to get the molar mass of water. Isn't that 18 grams for every mole? But how do we get copper chloride? Isn't it copper plus 2 chlorines? That's going to be 63.5 plus 35.5 times 2. Okay, 63.5 plus 35. I'm just going to type them in twice for my sake of typing it in. And that's going to be 134. That's the molar mass of copper chloride. Okay. So we have waters. This is water. This is copper chloride. Okay. So you're going to take your grams of copper chloride and use the molar mass to get to moles. You're going to use your grams of water with 18 to get your moles of water. Okay, so we have to convert grams to moles of water and of copper chloride. So water's moles is going to be the 0.96 divided by 18, and the copper chloride is going to be the 3.54. You're going to use the dry compound, 3.54 over 134.5. Okay, and so you're going to get moles of each, just like we did on step 3 and 4 on the other side. So we're going to take 0.96. 0.96 is going to be, okay, hold on a second. I thought I had it written down, but I don't. 0.96 divided by 18 is 0.0533 moles of water. And then this one is the moles of the dry compound is 3.54 divided by 134.5, and that's 0.0263. Okay, and you usually will always have either equal. If they're equal, then they're 1-to-1, but you usually will always have water moles higher than the compound moles. Okay, so what you're doing next on step 3 is that you're going to take the moles of water as a ratio over the moles of copper chloride dry. Okay, that's your third step. And you're going to take 0.0533 divided by 0.02063. Okay, and when you do that, I'm running out of paper space. I'm getting another sheet of paper here. You're going to get a value, because you're going to take 0.0533 divided by 0.0263. Okay, 0.533. See how it's higher? That's probably going to look like twice to me. 0.533 divided by 0.0263, and you're getting really close to 2. Okay, so that equals 2.026, which is really close to 2, which means that's the whole number that's beside the water. That means copper chloride is going to have 2 waters. That's what you're doing. You're trying to solve for the X by doing a mole-to-mole ratio. Okay, so I'm going to have you guys work on some more problems Thursday in class. I'm going to have the 3 steps emphasized again for you to go through, get the grams of water lost, convert your grams of water to moles, your grams of dry compound to moles, and then once you have the moles of each, you're going to divide the water moles over the the dry compound moles to get an overall number of whatever that is, the whole number. Okay. So go ahead and stop it here. Try to get these notes. If you need to stop your video to get the notes written down or the examples, go ahead. I'm going to go ahead and turn this off, and then you guys work on the set of like 5 to 6 questions I'm going to have as a post test of today's lesson. Okay. See you later. See you guys. Bye-bye. See you later.